All right, gang, Math 5130. Really cool video here. We're going to dive into variability, and I'm going to venture out of PowerPoint and take a look at R and StatCrunch and show you how we make some very, very basic calculations that are demonstrated in this video. So let's get to it. Key concept here is variability. When we are describing sample data, again, I went on my rants in the I think the last two videos. So if you need to rewatch that, please do. But when we describe sample data, we want to make two statements. We want to make a center statement and we want to make a spread statement. Our center statement will be made by the mean and the median. Our spread statement will be made by the range, standard deviation, and IQR or quartile, something we'll study, I think, in the next video. So the purpose here is just to introduce these ideas to you and hope I can describe it well enough where you can understand what they measure. But again, range, that's the first measure of variability. It's the easiest to find because it's just the biggest number minus the smallest number. The problem with the range is it can be artificially inflated if the high number or the low number are outliers. So they've given you 5 numbers here. It's kind of nice because we could just eyeball it and we can see the biggest number is 520, the smallest number is 210. So take the difference and we get 310, which is the range. Now, imagine that 520 was replaced with 1,000. Then our range would go from 790, or I'm sorry, it would go from 310 to 790 just because one value changed. So again, if one of the extremes, the high number or the low number, is an outlier, then we can artificially inflate the value of the range. And that's one reason we don't. I always report the range, but I don't really look at it. When I analyze sample data, I'm really more interested in what is the minimum value and what's the maximum value. I don't put a lot of stock in what the difference of the two is, but nevertheless, we do report these. Standard deviation, depending on whether we're in a sample or a population. If we have a sample standard deviation, which we typically will, the notation is S. And if we have a population standard deviation, which is typically unknown, we have the Greek letter sigma. I think of standard deviation as it is a measure of center around the mean. Now, we're going to run into something called quartiles in the next video. Those are measures of center around the median. Standard deviation is a measure of spread around the mean. You can kind of see that with this formula. I'm a math geek. I'm not trying to turn any of you into math majors. But if you look at the inside, and I'll try to circle this here, the very first thing we do is we take each x value and subtract it from the mean. So again, looking at the mean is kind of the measure of center. We're seeing how far each value is from the mean. We square it and divide by the degrees of freedom and all that stuff. Don't worry about it. If we need standard deviation, we are going to use statistical software. So an example, we have some numbers here. I'm going to write these down real quick, and I would encourage you to as well. So we have 362, 210, 400, 520, and 360. So the first thing we would do in calculating the standard deviation, if we calculated it by hand, which we'll never do, is to find the mean, and you'll see the mean is 370.4. Notice that we use X bar to represent that mean because this is sample data. Next thing we do is we do some fancy stuff. We subtract from the mean, we square all this stuff, we sum it up, get 49,000, whatever. Don't worry about that. Next thing we do is divide by what's called the degrees of freedom. Forget I said that. We just divide by stuff, get 12,290.8. Then we take the square root, and we get, in this situation, that S, our standard deviation, is 110.9. All right? Now, we also talk about the variance. And the variance is this value up here. It's the 12,290. It's the value we get right here that we take the square root of to get the standard deviation. The variance is typically a rather large number, and the variance is in units squared. The standard deviation is in units of the measurement. So it's important to keep that in mind. So let's say that our measurement was in grams. Then the variance would be units grams squared. The standard deviation would be units grams, the original measurement. So ng per ml must be the original measurement. All right, so notation summary, if we're dealing with a sample, which we typically will be, S is our standard deviation, S squared is our variance. If we're living in a population, then, or we have population data, then sigma is the population standard deviation. Sigma squared is the population variance. And this is just what I talked about, the units. And the value of the variance, the value of the standard deviation can increase drastically when we are in the presence of outliers. All right, let's scoot over here to my stat lab. So you're going to have an account, which you're going to sign into. You're going to find your My Stat Lab course page, course site. It's not created yet. It'll be unique to the class that you're taking. And again, I'll post a video later about how you navigate all this stuff, and so don't get too crazy on me just yet. All right. But if we'll come down, something I want to demonstrate in this video is StatCrunch. This is the statistical software, one of the statistical software packages that we'll use. Now, you can see right here, these are data sets from your textbook. If I click that, then I go to this other page where it lists data sets that are affiliated with healthcare stuff. It's kind of cool. We'll use that. Another way to access StatCrunch is within your homework assignments. You can access a data set that you're asked to evaluate in your homework assignment. I'll demonstrate that in another video. But for right now, I just want to go directly to the StatCrunch website. And when you get this, again, you can go to data you may have stored. You can go to data set. You can upload that, whatever. Okay, but I just want to open StatCrunch. And I want to enter my data. So before, I told you to write this down. We have 362. We have 210, 400, 520, and 316. So those are the numbers we had before. Now, if I want to, I can come up here and change the variable name. I forget what these actually were. Let's just call it our data. I don't know, whatever. Okay. So these are our 5 measurements. Now, if I want to find the standard deviation and the variance of these 5 numbers, I can come to Stat, I can come to Summary Stat, and I can go to Column. All right, go to Column. I want to move data over here because I could have multiple variables. So I want to tell StatCrunch which variable, and I just call it data because I wasn't very clever. And I forget what these measurements actually stood for. I don't want to group anything, but then I come down to the statistics that I want. So let's just go ahead and let's just calculate the median, and let's calculate the variance, and let's calculate the standard deviation, And let's just scroll on down and calculate the median. Now, depending on the type of calculator or the computer you have, I have to control or hit command to select these. I'll tell you what, let's just go ahead and get the range as well, because we talked about that in the video. Now, when I hit compute, just magically almost, we can see the mean is 370.4, which we saw from the video. The variance, 12,290.8, as we saw in the video, and the standard deviation is 110. The range was 310, the median 362. So we get these values without any, confusing formulas. We get these values, and we can report those in our summary of our sample data. Now, okay, let me pump the brakes a little bit. Why StatCrunch? Well, first of all, StatCrunch is free with the Pearson textbook, right? The Pearson MyStatLab, that's what we call it, our course management site. I chose this because ideally I would have used SPSS, but SPSS is extremely expensive. So I'm trying to save you guys some money. But I think StatCrunch works a lot like StatCrunch, works a lot like SPSS. The problem is not everything that we do in this class. For example, I'm going to want to eventually do some logistic regression. Logistic regression in StatCrunch is limited because we can't have categorical predictors. So I will also use R. Now let me show you what R is. R is a statistical software package that is free, but it requires a little bit of coding. Now, before you flip out on me, I'm not going to ask you to do anything in R that I won't demonstrate exactly in an instructional video. So if I wanted to find the mean and the standard deviation, what I would do is just type in, and I have to use the command that R requires, so I would need to call it something, call it data. This is just the sign for equal to, so my data is equal to. C is a string, which says this is my data. I can't just enter the data as 362, 210, and so on. I have to enter it after the C. Why? Well, we're communicating with a machine. To find the mean, I just do the mean of the data, and you can see it's 370.4. Standard deviation, SD, of data is 110.87. If I want to find the variance, just the variance of the data, the 12,290. If I want to find the median of the data, it's 362, as we saw before. So R is very powerful. I much prefer R over StatCrunch, but I will demonstrate both, and then you'll be able to choose which one you want to use. Now, when we get to logistic regression, we have categorical predictors. We're going to have to use R, so I hope along the way you'll kind of stay semi-familiar with using R to make commands or make calculations. And you can see that the commands are straightforward. We're not gonna get crazy. I'm not gonna require you to do anything, again, that is too insane. All right, gang. That is all I have, I believe. I believe it was, yeah. All right, take care.